Hi everyone, welcome to my channel, Tutorlini Test Prep. Today we'll be going over 7 hard problems for the December 2023 DSAT. Problem Sette number 4. The goal of the Problem Sette series is to provide an original worksheet of challenging problems right before the test date. This gives students the opportunity to push themselves while also reviewing a variety of topics. Please download the worksheet for free using the link in the description and attempt the problems yourself before watching this video. Let's get started. Okay, this first one is definitely a quadratic formula question. What's kind of cueing me in that the answer is going to be irrational and I'm going to want to use quadratic formula is this minus and then the square root. The final answer of an irrational quadratic formula problem tend to look like that. And I'm going to make a card on this and post, guys. I have a short going over all these steps. I'm going to go through it a little bit faster here. I'm going to kind of assume you've watched the short. So, first we're going to identify ABC. So A is 1, B is negative 12, and C is 7. Next, we're going to write down the quadratic formula, which is negative B plus or minus the square root of B squared minus 4AC all over 2A. And next we're going to plug in those values just without doing any math. So negative 12 plus or minus the square root of negative 12 squared minus 4 times 1 times 7 over 2 times A. So 2 times 1. And this gives us, now we can start kind of cleaning up the three sections, right? So negative 12 is 12. 2 times 1 is 2. And then that radicand should be 144 minus 28, which gives us 116. Next, if possible, we really want to simplify the radical. So we're going to do that by hand now. So I'll just do it kind of off to the side up here. So the biggest perfect square that I think goes into 116 is 4. So I'm going to pull out a root 4. And I'm going to just use a calculator really quick, see what's left. 29. The square root of 4 is 2. So this would be 2 root 29. So we're going to replace this guy. 12 plus or minus, instead of root 116, we're going to write 2 root 29 over 2. And now to get it to look like our final answer, we are going to split the fraction. So let's do that. So that over that, and then this over this. So our answer will be 6 plus or minus 2 divided by 2 is 1. So this is just square root of 29. So our two answers are 6 plus root 29 and 6 minus root 29. And you'll see that the question writes j minus root k. So that is talking about this one, j minus root k. So j is 6, and k is 29. So that means that, let me do this off to the side over here, jk is equal to 6 times 29, which is equal to 174, and that is our answer. Great, stupendous. So it's worth mentioning that if you brought a scientific calculator with you. I also have another video on this, I have a CASO video going over this. If you brought a scientific calculator with you, you could have done this all on the calculator. I will show you that right now on my scientific calculator. So give me a second. So let me kind of X out here and switch to this. So I'm going to go to polysolve 1, -12, and 7. And you see the two answers are 6 plus root 29 and 6 minus root 29. That would have saved me a ton of time, so I highly recommend you bring a scientific calculator with you, and you learn how to use it for the couple things that it will be helpful on the test. Great. Okay, let's come back over here and move on to the next question. Okay, so there's a lot kind of going on with this question. So it says we want to find BDC, which is this one here. They've asked us quite a bit on the test before, like this exact shape. So what we want to do is, very first thing we want to do is we want to basically split this kind of quadrilateral in half right here. The reason we want to do that is because AD is a radius, DC is a radius, and BD is a radius. So you kind of see each of these triangles becomes isosceles triangles because all radii are equal to each other, right? So isosceles triangles, the base angles are equal. So you see, for example, for this triangle on the right, this one and this one would be equal. So that means that 19, that means this guy is also 19 over here. And then the same is true with the left triangle. That guy's 19, so this guy is also 19 because they're isosceles triangles and their base angles are equal. Okay, now we can kind of deduce that because those guys are both 19, we can say that that whole thing is 19 plus 19, which is 38. So I'm going to erase this, and I'm going to put this guy as 38 degrees. Okay. So now where do we go from here? So now it's really important that you understand central versus inscribed. So I'll go over that really quickly here. So central angles carve out the same measure of arc that they measure. So for example, if this guy is 60 degrees, that's a central angle. See how the angle, the vertex of the angle is on the center? So this arc that it cuts out is also 60 degrees. Inscribed angles do not work like that. So inscribed angles, they follow a different relationship. Those are angles where the vertex is on the edge of the circle. I've talked about this in my other videos. I don't have a designated video for it, but so let's say this guy is 40. This arc would be double, which is 80. So that's kind of the idea. So when you see an inscribed angle, often you have to multiply by 2 or divide by 2. So make sure you understand that. Okay, so we have a 38 degrees, and hopefully you guys are kind of seeing now. Oh wait, that's an inscribed angle. See how that the point is on the very edge, the vertex on the very edge of the circle. So 38 times 2 gives me 76. So this arc here is 76 degrees. And you see the one that we care about, this one is a central angle. So the central angle is equal in measure to the arc that it carves out. It carves out the same arc, so this central angle must be 76 degrees. So that's kind of how you go through these problems. I'm going to put a big box around that because we're going to need that. Kind of notice, right, for this particular shape, it'll always work out that, you know, oh, you just multiply by 4 or divide by 4 or multiply. You're always multiplying by 2, dividing by 2, multiplying by 4, dividing by 4. Again, it's probably best if you understand the concepts for when you come across other questions where these concepts are helpful. So the first thing we went over was the base angles theorem for isosceles triangles. And the second thing we went over was central versus inscribed angles in a circle. Great, so now it just wants us to find that angle in radians. That's like a very routine thing. It's just something you gotta memorize. So the conversion factor for radians and degrees is pi radians equals 180 degrees. Just something you gotta memorize, unfortunately. They're not gonna give that to you on the exam. And we are going to do 76 degrees. And we're going to put 180 degrees on the bottom. And pi radians on the top. And the degrees will cancel because they're on opposite side division sign, and we're left with radians. So now you can get out a scientific calculator and just type this in. Or you can just use Desmos and just kind of ignore the pi and just remember to put the pi at the end. So why don't I do that since we already used the scientific calculator. So, okay, 76. Okay, so it's telling me 19 over 45, but remember I didn't put the pi, guys. So in our answer, we're going to put 19 pi over 45 radians. Great. And again, if you have a scientific calculator that can handle pi, you don't even need to worry about that. Okay, let's keep going. So we're basically done. Now it says it wants to find the smallest possible value, so that just means it wants us to be simplified in lowest terms, which this guy is. So a pi over b radians, let's write that down. A pi over b radians. Hopefully you guys see that a is 19 and b is 45. So a plus b is going to be 19 plus 45. Let's see what that is. That is 64. So that is going to be our answer for this one. Great, so lots of things going on in this question, just lots of tiny things to help you review for geometry. Let's keep going. That one's right. Okay, so for this thing, first we're going to do let's do the function notation first, then we'll talk about absolute value equations because we're going to need to talk about that for a while. Okay, so f of k, so just replace everything with a k. So f of k equals the absolute value of 8 minus 5k. And that is equal to, they say, 6k plus 3. And we don't really care about this f of k portion. So that's our equation. And I'm going to move that maybe over to the center a little bit more. So I'm going to pause the video and pull up some notes and just talk about absolute value equations really quick. Okay, everyone, so the first thing you need to do, I've talked about this in other videos already, but first thing you need to do when you See, an absolute value equation is you need to get the absolute value by itself. On the SAT, it's almost always already by itself, or you can just use Desmos to solve it. We can use Desmos to solve this one too, but we'll get to that. So once you get the absolute value by itself, you look at the number that's on the other side, and that tells you how many solutions it has and what to do. So if the number on the other side, you get absolute value equals negative, that's impossible. So that just has no solution. Absolute value can't be negative. If you have absolute value equals 0, there's one solution. To solve it, you just drop the bar. So in this example, I did x minus 4 equals 0. And if it's got a positive number on the other side, then it has two solutions. One where you drop the bars, and one where you change the stuff on the other side. You multiply it by a negative. So x minus 4 equals 2, and then x minus 4 equals negative 2. Then you solve both those equations. And you get two answers for that one. Okay, so the one we're about to do is a little bit different. So let's go back and talk about it. Okay, so I didn't just come up with this. They've actually already asked this in the Blue Book test, so it's kind of like a new thing they kind of expect you to know. So notice, guys, we have an absolute value, and then it's equal to, it's not a number, this is an expression. So we don't know if 6k plus 3 is 0. We don't know if it's negative, 0, or positive. So we don't know how many solutions this equation has. So what you do in that situation is you just kind of assume that it has two solutions. Assume that it has two solutions. And then check for extraneous, like check to make sure that any of them are wrong. So we're just kind of going to hope and be like, oh, let's just hope it has two solutions and then see if it works. So that's kind of what we're going to do. So we'll go through both of them. So the first one will just be 8 minus 5k equals 6k plus 3. And then the second one will be 8 minus 5k equals negative everything on that side, 6k plus 3. So notice how I put a parentheses around it. That's really important. Again, very similar to the third example, x minus 4 equals 2. Very similar. Okay, we're going to solve both these. So the first one, why don't I add 5k to both sides, and I get 8 equals 11k plus 3. Now I'm going to subtract 3 to both sides. I get 5 equals 11k. Now I'm going to divide both sides by 11, and I get k equals 5 over 11. And for this one, first I'll distribute. So 8 minus 5k equals negative 6k minus 3. And I'm going to add the 6k. So I get k plus 8 equals negative 3. Now I'm going to subtract 8. So k equals negative 11. I think I did that right. Let me check. Yeah, that one works. That worked. That worked for that equation. Okay, so now we have to go and plug them back into the original. So 5 over 11 would give me 8 minus 5 times 5 over 11. Which gives me the absolute value of 63 over 11, which is just 63 over 11. And now let's do 6k plus 3. So 6 times 5 over 11 plus 3. That is also 63 over 11. So we get 63 over 11 equals 63 over 11. This is correct. That's probably our answer. Now let's look at negative 11. So if we do 8 minus 5 is negative 11. we get 63. The absolute value of 63 is 63. And then if we do 6 times negative 11 plus 3, we get negative 63. Ooh, that seems no good. So this one is wrong. I'm going to put a big X to that. That is an extraneous solution. So it just so happened that this one ended up having one solution. It just so happened. We just assumed it has 2 just in case it did have 2, right? So the answer is 5/11. Now, you could also solve this one, at least once you got to this point, once you figured out how to write this equation, entirely on Desmos. So that's what we're going to do now. So let's go to Desmos. And I'm going to first just try to type see, so I typed it in, right, and it doesn't let me click because there's absolute value. So, you know, what I'm going to do is I'm going to do the Desmos lesson number 1 way, where I break it into 2 equations, kind of the old-fashioned way. So y equals 8 minus 5x absolute value, and then y equals 6x plus 3. And you kind of see, because the way the slopes of these lines play out, it only crosses once. And it tells me 0.455. And I just made a video on this, guys. I just made a Desmos video on this. It's called Student Produced Response. Check it out. If you include the 0, that would be marked right. So if there's more answers, right? But if you, let's say you did it using Desmos, right? And you put 0.455, that would be marked correct because that is rounded to 5 characters. So even if you weren't able to figure out that it was 5/11, you still could have gotten the answer right. Just make sure if there's an optional 0 in front that if you include it, I go over this in the Desmos 18. If you just put 0.455, that would not be enough precision. So make sure you put that 0. Anyway, man, the definition of a question you want to get right. You could have had no idea how to do any of this, and you could have still gotten it right if you knew how to use Desmos. All right, let's keep going. What is the next one? Okay, so this is a scatter plot. The most important thing to understand for scatter plots is that the actual y values are dots, and the predicted y values come from the line. So if the question is asking you about the line of best fit, you should be looking just at the line. See? Just be looking at the line. All right, anyway. So this one says there's 10 students. That just means there's 10 dots, which there is. And it says the line of best fit underestimates one student's reported energy level by more than 3 points. So underestimate is, by the way, the one student is a dot. That's an actual student. So underestimate means the line, which is your prediction, your estimate, is underneath that student by more than 3. So we're only looking at students that are above the line, because those are underestimates. I know that feels a little counterintuitive, right? So I'm going to look at all the ones that are above, and I'm going to draw little vertical lines. In statistics, we call this the residual. The SAT will never call it that because they don't expect you to know that word. And I'm going to pause for a second, and maybe you guys can see which one is underestimated by more than 3 points. So see if you can figure that out. And it is this one. This is the student they're asking us about. See how just barely a little bit past 3. It's underestimated by a little bit more than 3. So that's the student it's asking us about. So now we just have to answer the question. It says, what was this student's reported energy level? Okay, so just be very careful. Does it want the y value or the x value? Well, it seems like energy level is on the y, so it wants the y value, which is 9. So his energy level was 9. And that is the answer. So, just quick little review. I don't think you'll see these words on the SAT a lot, but they will find very roundabout ways to ask you about which ones are above and which ones are below. And one of those sets of words they use is underestimate and overestimate. So let me add this to the board. The ones that are underestimates, those guys are above the line because their estimates are underneath them. That's the idea. And the guys who the line overestimates what their actual energy level, they are underneath the line, so they're on that side. So if the question was asking about an overestimate, we'd maybe be looking down here. And again, you can draw these nice vertical lines to kind of figure out how much it's being overestimated or underestimated by. Great, let's keep going. Okay, this is a literal equation. And I tried very hard, guys. I think this is a real equation based on molal boiling point elevation. So first, let me rewrite the equation because I don't think this space over here is enough. So I'm going to rewrite the equation maybe down here. So K equals... And these take a ton of practice, guys. You can't just get good at these overnight. (1000H). And I'm also going to write over here PEMDAS. And then this little arrow to indicate that we're going to kind of go backwards. Reverse PEMDAS. And the thing we're trying to, you can tell this just by looking at the answer choices. You don't even need to read the question, really. We're trying to get T by itself. See how they all say T equals? So I'm going to put a little box around T. Okay. So first things first. I don't really have any addition and subtraction, so we don't need to worry about that. So I can just kind of scribble that out. But this actually isn't just multiplication, division, left, right. This is a fraction bar. So when you have a fraction bar, regardless of where the variable is, you probably want to worry about the stuff on the bottom first, just kind of getting rid of it. So this stuff is being divided. The opposite operation of division is multiplication. So I'm going to multiply both sides by 1000H. And sure enough, these guys will go away because they're on opposite sides. And we will be left with 1000HK. We tend to put the letters in alphabetical order. It really doesn't matter too much. On the SAT, they don't always follow the conventions to a perfect T, so just try to get it to look like what's in the choices. As long as you can do that, you're fine. Okay, so now we're left with RT squared M. And again, we want to get T by itself, so let me put a box around T. So, Division is kind of done, so we can get rid of him. So now we have exponent and multiplication. So you see we're kind of going in reverse up the tower. So we're going to do multiplication next. So the things that are being multiplied to the thing we want to get by itself are the R and the M. So I am going to now, the R and the M are receiving multiplication. The opposite of multiplication is division. So I'm going to now divide both sides by RM. Let me fix that. Okay, so this guy goes away, this guy goes away, and we are left with 1000 HK over RM equals T squared. Again, we still want to get this T by itself. Let me put a box around him. And we're going to now, we're done with multiplication, so now we're just going to do the exponent. So to get rid of the exponent, the square, we are going to take the square root of both sides. So let's do that, square root of both sides. And I'm going to just also just kind of flip things around here. So square root of t squared, that's just t. And then we get square root 1000 HK over RM. Let me put a box around that, even though I don't think we're done yet. Great, so we kind of worked our way up this little tower. It can be more complicated than that. Frankly, you need to do probably hundreds of these to get really good intuition on what you need to do. But that's kind of a good, if you're stuck thing to try, is just be like, oh, let me do any addition, subtraction? Nope. Any multiplication, division? Nope. Anyway. Okay, so now I'm looking at my answer choices and I'm like, does this look like any of the answer choices? And first of all, I'm like, okay, A and C are nowhere near correct. Those are probably from some conceptual misunderstandings. And it doesn't really quite look like D either, because the 1000 is pulled outside the square root, which we can't do that. So I'm going to try to do something to make it look like B. What I'm going to do is I'm going to simplify the radical. And you could do this on a calculator, a scientific calculator. But I'll just do it by hand here. So I think the biggest perfect square that goes into 1000 is 100. So I'm going to pull it out on the left side. And it would be 100 times 10. The square root of 100 is indeed 10. So this would be 10 root 10. So I'm going to rewrite this guy as 10 square root 10 HK over RM. And I think technically we should put MR because alphabetical order, but it doesn't really matter too much. And that is looking like answer choice B. So you see, it's like, it doesn't really matter if what you have written is correct. You have to make it look like the answer choices, unfortunately. And like I said, the only way to get good at these is to do hundreds and hundreds and hundreds of them. And literal equations are basically on every single exam, so it is something you need to know how to do. Great. Okay, that one is pretty good, I think. Let's keep going. Okay, here's something else we right away need to talk about at the whiteboard. So let me pause the video and pull up some notes. I've talked about this before in a lot of my other videos, but I'm just going over this simply because I don't have a designated video that I can point you guys to. So first things first, there's two equations that they sometimes just want you to memorize at the top. Sine of theta equals cosine of 90 minus theta, and cosine of theta equals sine of 90 minus theta. But the important thing you understand is these two properties. So if x plus y equals 90, then sine of x is equal to cosine of y. And if sine of x is equal to cosine y, then x plus y is equal to 90. So you'll notice the second one is what this question is testing us on. So we'll go back and do it in a second. You just might want to take a second to write this down. I'm also going to scroll down a little bit. These are the two most common examples of pictures where they'll expect you to realize that x and y add up to 90. So in a right triangle, the two acute angles add up to 90. Think about it. 180, you take away 90 for the right angle, and you got 90 left. So those two must add up to 90. In the picture on the right, you have a right angle, and then these two angles touching. Those also add up to 90 because they form that bigger 90-degree angle. So if you see either of those two pictures and there's mention of sine and cosine, you might want to start thinking about this almost right away. Anyway, very niche, random, rarely tested topic, but important for 700 plus scorers. All right, let's keep going. Let me go back to the questions. Okay, so right away, I see sine of A equals cosine B. As we just talked about, if sine and cosine are equal, then the two angles should add up to 90. So I know A plus B is equal to 90. And this second sentence tells me an equation. The number A is 70% greater than the number B. So we're going to do a percent multiplier. In this case, it's an increase. Greater is an increasing word. 1 plus percent divided by 100. So let's go over to Desmos and just do that really quickly. So 70% greater. 1 plus 70 divided by 100. That's 1.7. Why don't we just write that down really quick? 1.7. Okay, great. Let's come back over here. Okay, so A is means equals 1.7b. 1.7b. That's kind of how that translates now that we have that nice handy dandy percent multiplier. Man, percent multipliers are really helpful on this test. All right, so we have a system of equations, so I'm going to do substitution to do it by hand. We could always do it, you know, by using Desmos later maybe. So I'm going to put in that A there. 1.7b plus b equals 90. 1.7b plus 1b is going to be 2.7b. And now I'm going to do 90 divided by 2.7 just on my calculator. And I get 33.333 or 100 over 3. Which is good. But it wants us to find A. So now I'm going to go back to, how about that A plus B equals 90? And I'm going to put in A plus 100 over 3 equals 90. And I'm going to subtract 100 over 3 from both sides. And I get A equals 170 over 3. And that should be our answer. 170 over 3. If you watch the student produced response video, we've got 1, 2, 3, the slash, and then the 3. So 5 characters. So it will fit in the Blue Book app, so this is acceptable. No reason not to use the simplified fraction if it fits. Okay, great. Now we could do this on Desmos if we wanted to. You would just have to change the A and B to X and Y. So let's do that. X plus Y equals 90. And then X equals 1.7Y. And then you get the same thing. 170 over 3 is just 56.6666. Which you also could have put in. You could have put in 56.66. That would be 5 characters, and that would be truncated, which is correct. Great. Okay, let's come back over here. There's one more, I think. Okay, for groups of 28 or more people, an arcade charges $9 per person. Okay, so I'm going to write a linear equation for this. The first, I'm going to make x the number of people. And y the charge in dollars. And let's see here. They told us for 28 people, they get charged $9 per person. So that's 28 times 9. That's $252. So that's a point. And then after that, they get charged $15 for each person. So when x is greater than or equal to 28, we have this slope, we have this point, and we have this slope of 15. Each additional person. It's a slope word. So what we're going to do is we're going to use point slope to come up with the equation. So y minus y1 equals m times x minus x1. So y minus 252 equals 15 x minus 28. I'm going to add the 252. And now we're going to distribute. So this is 15x, 15 times negative 28, is negative 420. Negative 420 plus 252 is negative 168. So we now have this equation when x is greater than or equal to 28, where x is greater than or equal to 28 people, for the total charge that got spent in the arcade. Great. Now it says the group paid $447 to go to the arcade. So I'm going to put in 447 for y. We'll add 168 to both sides. So 447 plus 168. And we get 615. And now I'm going to divide by 15. And we get x equals 41 people. And that should be our answer. And of course, yeah, I mean, there's a lot of stuff you could have done, but you could have very, very early switched to Desmos and solved this. So let's do that. So I'm not even going to solve it. The equation we got was y minus 252 equals 15 x minus 28. And we know they spent 447, so that's y equals 447. And I'm going to zoom out. And sure enough, tells me 41 people. So that's what I would have actually done on the test day. Though when you're practicing at home, work on your algebra is really important, just in case. You never know. Okay, great. Okay, that completes the lesson. Please like and subscribe for more digital SAT math content. If you're interested in my tutoring services, the link to my website will be in the description. I tutor SAT math and all math subjects from about 7th grade to AP/early college level. Thanks for stopping by, and good luck studying.